Go. Hello and welcome back to Statistics 1, section 7.2 on the mean and standard deviation of the sample mean. Last time, in 7.1, we discussed the sample mean. We took a population, and we took some small population, right? So we can actually do this. And we created all possible samples of a given sample size. So you can compute how many of those you would get. It's just important to list all of them. And then we found means of each one of those. And just as a fun, we found mean of means. And then we found out that the mean of all of those means, and those means were means of each sample individually, were the same as the mean of a sample. We also found out that the bigger the sample size, the individual means of each sample were closer to the population mean. So from 7.1, from that exercise, right, which was very tedious, very annoying, to calculate, to find all of those samples and then to calculate all the means, we found out those two things. Number one, the more we have in a sample, the better the mean approximation is. And then if we were to sit there and find all samples that are possible and find all of their means and then take the mean of the means, it was the same as mean of population. So today, we get to put that second conclusion we made into an official, it's not a formula, it's just a statement, and then talk about standard deviation and be done. I hope you're not disappointed, but it's going to be short. Right? So the first one is the formula. I think I call it formula 7.1, whatever. So mean of the sample mean. For samples of size n, the mean of the variable x bar, and those are all individual means, equals the mean of the variable under consideration. And the formula says that mean of means is equal to the mean of the population. So I'm going to box this. This is what we discovered last time. And I'm just going to point the arrows into this and say, this is your mean of means. And this is your, say, population mean. So this is what we discovered last time. Now, in order for us to quickly go through this example and exercise, you know what? I'm just going to go with the standard deviation first, and then we're going to deal with the example, so we can do both at the same time. Now, standard deviation of the sample mean So it's the same deal for the samples of signs. Then the standard deviation of the variable x bar equals the standard deviation of the variable under consideration, and it's just, here it is. So standard deviation sigma of x bar is equal to sigma divided by square root of n. So this is our formula. And now I point some arrows. That will be population standard deviation. And this is the sample size. Right, and that's it. So let's take a look at an example where we get to calculate these. So what I'm going to do? Well, let me see if there are any civil homework exercises. Sample size, let's do sample size 4. So basketball players, they give us basketball players. So NBA players, they do list the names and stuff, but they're focusing on heights. So the heights are 83, 76, 80, 74, and another 80. Sample size, n equals 4. So they want to compute. Now, on a basketball team, right, there are 5 players playing. So now what we do is we find all of the samples of the size 4. So clearly the first 4 numbers would create one such sample. So 83, 76, 80, list them next to it. 83, 76, 80, and 74. And then 83, 76, 80, and another 80. And then 76, 80, 74, and 80. And that's it. We can't find any more, because you have the first 4. Yeah. Sample size is 4. Well, you can get any sample size. Let's say you don't want to measure them all, right? So that was the trick. We want to just show that if you're choosing sample sizes, they are the numbers that you're getting are the same, right? That's the idea. So we have x bar 1, so the first mean, and we have to calculate all of these now. So we are going to add all of these numbers. So the first bar mean 78.25, and then x bar 2 is 79.75, and finally x bar 3 77.5. Now, to find mean of means, you will add these numbers and divide by 3 because we only have 3 of them. And we get 78.5. So what we got is that the mean of means, right, which is the mean of the sample mean, is 78.5 inches. Now, what we saw earlier is that number must be the same as the population mean. Now, we have 5 players, so that's going to be, we add all of these heights, and when you divide by 5, you must get the same number. Now in my calculation something went wrong somewhere because I'm getting 0.6 instead of 0.5, so I probably typed something wrong. I typed in something wrong somewhere because we shouldn't have any rounding error anywhere. So these, they should be the same. So something is wrong somewhere. I'm sorry? 78.75, so I typed something wrong. Thank you. So then that should, yes, that's going to increase this to 6. Great. So that's the mean. And now to find the standard deviation of these means is the regular standard deviation, population standard deviation divided by the sample size n. So we actually have to sit there and figure out the standard deviation, which is that chart. Right? We have the data, which was 83, 76, 80, 74, and 80. Then we need to have x minus mu squared, and then we have to add those. So we are using 78.6 as our mean, so that's 4.4, negative 2.6, 1.4, also at the end 1.4, and 74, negative 4.6. So now we have to square each one of these. So the first one is 1936. 2.6 squared is 676. 1.4 squared is 196 twice, and 4.6 squared is 2116. Now, if you don't remember standard deviation formula, it was the square root of x minus mu squared divided by n. So, oh, summation, I forgot the summation symbol. There we go, much better. So now we have to add all of these values. I hope you get 51.2. Do you? Anyone? Thank you. So now sigma is equal to square root of 51.2 divided by 5. Because we have 5 in the population. Maybe I should use capital N here. That's the population. And then we take our number, divide by 5, and then take the square root of that answer for sigma of 3.2. So now standard deviation of means is going to be 3.2 divided by the square root of 4, which is 2, so 1.6. So we have that the mu x bar 78.6 inches with a standard deviation sigma of 1.6 inches. And again, you are picking one decimal here because your data had no decimals, so you go one extra decimal from where your data is. Since data had no decimal, then we provide one decimal in our answer at the end. So one decimal here, one decimal there. Good. So what are you remembering? You're remembering two boxed formulas, which are very easy. One more problem, and then we're going to take a look at the review, talk about the exam.
I have a question.
Yes.
For the standard deviation formula at the top, wouldn't the square root be for the entire fraction of the standard deviation of the sample size? Because I see it's only under.
Yeah, it's only on n.
But for the answer, we got the square root of the mean over the sample size.
Oh, you are confusing it now with, see, there's a, I should put a line here, right? So this calculation that I did here, including the chart, is to find, just to find this sigma here. So all of that stuff was just to find your good old population standard deviation you had on your previous exam. And then when you get that number, here is that number divided by the square root of sample size.
Okay.
All right, so there are two separate calculations. All right, let's take a look at 747, baby weight. The paper Are Babies Normal? Focused on birth weights of babies. According to the article, the mean birth weight is, so the mean birth weight is 3,369 grams. With a standard deviation of 581 gram. So these are all population data points. identify the population and the variable. Population or all babies, right? So A, all babies. And then variable is baby weight. Part B, for sample size of 200 babies, find the mean and standard deviation for all possible samples of mean weights. So now we calculate and we say that the mean x bar, which will also be 3369 grams, and then this one is 581 divided by the square root of 200. So 581 divided by the square root of 200 is 41.1 grams. It's 0.8, but so that's what they were asking for. And then part C, they want the same calculation just for sample size of 400. So mu x bar will be the same as mean, which is still 3369 grams. And now the standard deviation sample mean is going to be 581 divided by the square root of 400, which is 20. So 581 divided by 20 is 29.05, which is 0.1 grams. As you can see, these problems are literally 5 seconds. Obviously, if you don't know the formula, then they're impossible. But if you know the formula and you know what it means, what they're asking for, then you can do this very, very quickly. And that's it. So those are the two formulas that we are talking about. We talked about what this means, right? So we're taking as many samples as we can, and we are showing that the standard deviation, that the mean is the same as standard deviation as the relation of this sigma of the square root of n. Now, right now, to some of you that understand this, you would immediately say this is all pointless. And it is. Good. Because we don't do calculations this way. We are setting up the stage to do something extremely important. And that is to look at the sample and infer about population. That's what we are setting up the stage for. So these calculations here, no one does this, no one cares about it, right? The trick is that we get to flip these formulas later, and we get to say that this, in its similar form, times that is going to be predicting what this is, because you never have mean, in general, you don't have the mean and standard deviation of the population. So, and that's the thing that we want to know. We want to know the mean weight, right? We want to know the mean standard deviation and all of these kind of things. For weight, for height, for IQ, for shoe size, it doesn't matter what it is, right? We want to know the entire population. Because if you just want to know about yourself, you can go and measure those things, right? For your friend or someone in the family, sure, you can still measure all of those things. But how about the entire state, or the entire school, or the entire nation, or the entire planet? Right? What do you do with that? You cannot measure everyone and find exactly what it is. So we are going to turn this story around in the next chapter, 8. And we are going to start looking at these formulas backwards. And we will focus in chapter 8 we'll focus on the sample that we have, sample that we obtained, right? And that sample will give us a lot about population. So we're going to work it out backwards. That's it for now. Let's restart and talk about the exam. See if you guys have any questions. Anything about this before I switch off?
No.
Bye.